Hello, everyone. My name is Kinneret, and I'm the lead research community officer on the WMF research team. Welcome to this month's Research Showcase. Research Showcases are monthly convenings organized by our team to recognize and share recent research on or relevant to the Wikimedia projects. For those of you joining us live, we welcome you as always to ask questions in the chat, and we will transfer these to the speakers from YouTube at the end of each presentation. And as always, we kindly ask that all viewers follow the friendly space policy and the Universal Code of Conduct. Now, before we get started, I have one quick announcement. As you probably know, Wiki Workshop will be taking place over the course of 2 days on May 21st and 22nd, 2025. And Wiki Workshop is our annual convening, bringing together everyone around Wikimedia research. We are also happy to announce that our call for papers is out. I would like to encourage you to contribute by submitting 2-page extended abstracts to this year's workshop. Submissions can include ongoing, completed, or already published work, as the proceedings are non-archival. The deadline for submissions this year is March 9th, at the end of the day. I will add a link for the call in the chat, and we're looking forward to seeing your contributions and participations in this year's workshop. And with that, I'll pass it over to my colleague Eli, who will host today's showcase and introduce our theme and speakers for the month.
Thanks, Kinneret. My name's Eli, and I'm a researcher here at the Wikimedia Foundation, and I'm glad to introduce the January 2025 Research Showcase. Today's topic is reader attention and curiosity. In 2024, the world spent some 4.5 billion hours reading across all 300 plus languages available on Wikipedia. Wikipedia is a reflection of the world and the people who live in it. People come to read and learn about everything from pop culture to history to science and so much more. Today, we dive into the topic of reader attention and curiosity. And for this journey, we have two great speakers joining us today. We'll dive into examinations of different styles of curiosity through which we'll hear more about the busybodies, hunters, and dancers. And we'll also learn more about cross-platform attention and interaction patterns. Our first speaker will be Dale Joe, who's a Hewitt postdoctoral fellow at the University of California, Irvine, researching how we seek, value, and remember information. Merging computational neuroscience, cognitive science, and artificial intelligence, he investigates how knowledge graphs and narratives shape our ability to achieve complex and uncertain goals. His work builds models of curiosity, memory, and attention, and self-regulation by integrating brain imaging, theoretical modeling, observational data, and behavioral experiments. Dale received a PhD in neuroscience from the University of Pennsylvania, studying how brain function arises from dynamic interactions across networks of regions. Our second speaker today is Dr. Patrick Gildersleeve, who's a lecturer in communications and artificial intelligence at the University of Exeter, where he also co-directs the Critical AI Center. Before this, Patrick obtained his PhD from the Oxford Internet Institute and undertook a postdoctoral fellowship at the London School of Economics Department of Methodology. Patrick's a computational communications scientist interested in Wikipedia, the digital commons, and news across online platforms. Ultimately, Patrick aims to understand the social, editorial, and increasingly algorithmically mediated processes that shape collective attention and drive interest towards news events, viral content, and everything else across the web. After each talk today, we'll have about 10 minutes for discussion, and we're happy to take your questions in the YouTube chat. My colleague Caroline will monitor the chat and help relay those questions during the Q&A. And with this, let's pass it on to our first speaker. Over to you, Dale.
Thanks so much. Let me share my screen. Okay. Yeah, thank you so much for having me and inviting me to give this talk. As Eli said, I'm Dale. I'm a cognitive neuroscientist at UC Irvine, and I'm really excited to present some work I did during my PhD today on the architectural styles of curiosity in global Wikipedia mobile app readers. So I first want to thank some of the collaborators that worked on this project with me, including a team at the University of Pennsylvania led by Danny Bassett, our collaborator Perry Zerna at American University, and Martin Gerlach at the Wikimedia Foundation. And I especially want to shout out Martin and the Wikimedia team's work because the really careful curation of data and the amazing research tools, which I'll be citing liberally throughout, are really what made this work possible. So thank you. So I just wanted to start out by motivating why we're studying curiosity. One thing I believe curiosity research and Wikipedia has in common is that both exemplify a really refreshing and important way of resisting what some claim to be is a damaging model of learning and education. That model treats us as passive containers to be filled with knowledge, whereas in contrast, curiosity is a way of actively making choices to seek information without kind of standard norms about utility, but rather with intrinsic motivation. These information-seeking actions construct a dynamically changing way of how we understand ourselves and our connections with the world, and through the lens of our own personal histories. So what is curiosity? The practice of curiosity is defined in how we view it as patterns of information-seeking behavior that generate distinct knowledge networks based on individually different architectural styles. Studying curiosity is important because people tend to learn more when they're curious and may better critically assess the novelty and quality of false information. Curiosity is associated with well-being, creativity, empathy, and perseverance, as well as flexibility with gender norms, rebelliousness, unconventionality, and social perceptiveness. And curiosity declines in psychopathology such as clinical depression and anxiety. So given the importance of curiosity, what does it mean to study information-seeking behavior as what I said as generating distinct knowledge networks? So we define a knowledge network as a network with nodes, or the dots in this visualization to the right, as Wikipedia pages that were visited by a reader. And a pair of nodes are connected with an edge if there's a presence of a hyperlink between the pages. So using that hyperlink network of Wikipedia as an underlying map and a clickstream data for how mobile app readers kind of navigate or browse through that map, we can trace how each reader weaves a temporal thread of browsing that builds a personal knowledge network. Here I'm showing a network made from articles as nodes and hyperlinks as edges, where each color represents the browsing of a randomly selected reader. And one thing I really like about this visualization is that it shows just how much possibility there is for further exploration in gray with just one more click. So I'm showing you 7 readers, each colored with a distinct color. And some have called that kind of this boundary of proximal exploration in gray as kind of like this kind of idea of expanding the adjacent possible of the information that we can newly reach as we keep browsing and exploring. This visualization also really shows how differently different readers explore the underlying hyperlink network of Wikipedia, as each reader is covering different ground. So for example, the purple reader tends to explore all of one cluster of pages, whereas for example, the green reader doesn't and moves about in a more diverse way without necessarily exploring all of the pages within these cluster of pages. This specificity versus diversive curiosity has been observed in psychological research, and we propose a quantification of that specific versus diverse curiosity by analyzing the network structure that the readers create on these networks. So to quantify distinct architectural styles, and specifically these network structures, it's useful to get a richer understanding of what kinds of network patterns are signatures of different curiosity styles. So here our collaborator Perry Zern discerned 3 styles from philosophical texts from the past 2,000 years. So the first one I'll just highlight is where Plutarch said that the hunter keeps their sense of smell pure and untainted for their proper task in order that it may keep more keenly to the trail. Heidegger wrote that the busybody is never dwelling anywhere in a groundless floating. And Foucault wrote that for the dancer, curiosity throws off familiar ways of thought and is marked by scintillating leaps of imagination. So in our previous work, we've linked these styles to psychological research on curiosity using qualitative and survey methods. And specifically to do so, we, again, as people browse Wikipedia, we treated them as filling in a subnetwork atop the underlying Wikipedia hyperlink network. And as they traverse the nodes and edges, they can create their own individualized networks. So they could traverse it tightly, such as by visiting pages about the Queens of England and their lineage. Or they could jump around more loosely, such as by visiting pages about landmarks, media, and politics. And we can describe the form and organization of the networks that each individual constructs, and then compare this network structure to structures generated by different theoretical models and alternative models. So what we wanted to do was study curiosity more ecologically. And we thought that ecological studies are important because they assess the generalizability of what we thought was going on in our laboratory studies to the real world. And so we wanted to try to understand curiosity in a way that was informed by that idea, and also in a way that was informed by the biology of animal behavior, and specifically generalizing ideas from animal foraging to information foraging. So we had three major research questions that I'll talk about in this presentation. The first was, do previous hunter and busybody architectural styles identified in a laboratory setting replicate in a global readership? Are distinct styles of curiosity consistently related to readers' preferences across varied cultures and geographies? And are styles of curiosity associated with population-level variables such as education, mood, well-being, and inequality? So to test our ideas, we constructed hyperlink networks of Wikipedia in two data sets. We had, first, from our paper in Nature Human Behavior, we had 149 participants browse Wikipedia for 20 minutes a day over 3 weeks. And we found previously that how they browsed relates to a trait of curiosity concerning the intolerance for uncertainty. And we used ecological momentary assessments to track depressed mood and anxiety. But the data that we collect in the lab might not be representative of the data from people around the world. For instance, in the 3 weeks of laboratory data in the Philadelphia area, the participants visited 18,000 pages, which is a very small percentage of the total possible articles they could have visited in just English Wikipedia. So in collaboration with the Wikimedia Foundation, we applied the models from our laboratory data to much larger data sets from readers in the Wikipedia mobile app. To make comparisons between the lab and mobile app data fairer, we selected readers from the mobile app by matching for size and length of their browsing sessions to the lab sessions over a period of 1 month. And after all of that, we ended up assessing 14 languages of curiosity and like a bunch of these countries that I'm highlighting in this map over here. So this will allow us to test if our model from the laboratory and generalizes to a separate sample. As I said, one way we propose to study individual differences and the process of curiosity in the wild is to draw from theories of foraging, animal foraging in the wild. As a neuroscientist, I'm interested in developing this kind of theory where curiosity is a kind of foraging for valuable resources like positive experiences, treasured relationships, and information. What I'm showing you here is a levee flight, which is a particular type of foraging search pattern with a specific balance of short and long movements that generates patterns covering a large range. Consider this large range, especially compared to a more local random walk. Levee flights have been analytically and numerically supported to be efficient for the search of sparse and randomly distributed resources. So here, optimally efficient means that it maximizes the ratio of targets visited to the ratio of distance traveled. This might be why it's been observed across many organisms' movements, including human-made transport activity, albatrosses foraging for berries, mussels configuring themselves in different bed patterns to eat algae, and even cellular mobility of immune cells that move towards debris. We found previously that Wikipedia readers collectively approximated this kind of levee flight dynamics, where a greater type of intolerance for uncertainty called deprivation sensitivity was associated with more kind of repeated returns to a home base. So we fit this levee flight model to the laboratory data, and then we aim to test it on the data from the Wikipedia mobile app users. What I'm showing you here is 4 extremes of how the foraging model can simulate people's browsing on top of the Wikipedia network. What we're looking for are model parameters that generate movement trajectories that have signatures of a levee flight, where the 2 parameters define how regular the step sizes are and how often movements get repeated. And so you can see in the top left, you create these networks with a lot of these clustered bundles spanning kind of this moderate space. In the bottom left, you can see this more loose busybody-like construction of kind of like this kind of hairball nest. On the top right, you see this very tight hunter-like curiosity where you're exploring very deeply in a very constrained space. And on the bottom right, you have a very loose style of curiosity, but with many returns to previously visited pages. So this model can generate a really diverse collection of knowledge networks in between the extremes I just showed you. And so we think it's a promising model of that will generalize to mobile app data. Okay, so our first question was, do previous hunter and busybody styles identified in a laboratory setting replicate in a global readership? So on the x-axis, we can use network metrics to help us understand the knowledge networks people built, recalling that a hunter builds tighter networks, whereas a busybody will build looser networks. So I'll just go through these measures one by one. Clustering measures how likely nodes are to form tightly knit groups, whereas degree indicates the number of connections each node has. Path length tells us the average steps between nodes, giving insight to how loose a pair of nodes in the networks are. Core periphery structure distinguishes between a densely connected core from a more sparsely connected periphery. And lastly, modularity identifies community structures within a network, highlighting regions of tighter interconnectivity. So together, these metrics are what we'll use to kind of reveal the architecture of networks. On the y-axis, we can determine how different the mobile app data set is to different laboratory data sets and other sources across different languages. So showing these results, let me just highlight a few key takeaways. The most similar data set was, not a surprise to us, another Wikipedia mobile app data set that was collected 6 months prior to our main mobile app data set. This gives us confidence that the network measures we're kind of using here are a valid way of understanding these architectural structures. The next most similar data set was the laboratory data in orange, dark orange, to the mobile app data set. And on the right, let me go through the other data sets first. And the most different was this browsing data set by a set of people trying to find the shortest route between pages in the form of like this kind of targeted navigation game called Wikipedia, rather than more internally directed curiosity-driven information seeking. On the right, you can see the variation of structure across different languages. And the main point I want to make here is that the average variation of network structure across the laboratory and naturalistic data was within the variation of network structure across different languages. And what this suggests to us is that the range of network building in the lab generalizes to naturalistic data. So we can observe the same kinds of network structures we saw in busybodies and hunters across data sets. Importantly, this variation in the laboratory data can be checked to against several null models. And we can do this by calculating the distance of the mobile app data to different types of data sets generated by alternative models. So the takeaway here is that the laboratory data is most similar to the mobile app data compared to the alternative models of information seeking. And interestingly, the next most similar data set was our foraging model. And some of the data sets that didn't fit the readership so well were a random walk on the hyperlinks, kind of just random shuffling of a time series of browsing. These scale-free networks where you have this rich get richer property where people will go to pages that are highly visited by themselves, and this targeted navigation game from Wikipedia. So this allows us to get a sense of how similar the naturalistic data and the laboratory data are relative to other types of canonical organization structures. And we can get a different view of that same result if you look at this 2D embedding of all of our data on the right. So on the top right, we can see that the Wikipedia mobile app, laboratory data, and laboratory data are closest together. And we can also conceptualize curiosity in this space by considering that there are many different types of curiosity that can span this space. Okay, so our next question was whether there were distinct styles of curiosity consistently related to readers' preferences across varied cultures and geographies. We can study whether architectural styles have any relationship to topic preferences readers had by using tools developed by the Wikimedia research team. Here I'm showing you two people's browsing sessions over a month in blue and pink, and each page they visited was assigned to a course topic level and a finer grained topic level. We mainly focused on the course topic level here, which included STEM topics, so science, technology, engineering, and math, history and society topics, geography topics, and culture topics. And so we can see here that you can categorize a reader's proportion of topics visited as a proportion of their all of their page visits. We can also use the proportion of topics readers visited to calculate the topic diversity using what's called an entropy metric. So here we're visualizing each reader as a row in this figure and coloring their page visits as falling into one of those four course topics of STEM, history and society, geography, and culture. And what was really interesting is that despite significant differences in culture and geography, readers showed a consistent pattern of topic preferences related to their architectural style of curiosity across languages. So what we found was that if you browse more like a hunter, where you visit very similar pages and create these very tight networks, you will tend to visit or be drawn to STEM-related topics in Wikipedia. And in contrast, if you're more of a busybody browser and you construct these more loose and dissimilar and diverse networks, you'll tend to be drawn to more like of these culture and geography topics. And this is consistent with some ideas in psychology where you have these different topic preferences or interests for people and places versus kind of things and objects. The history and society topic kind of fell between the two styles, and we didn't find a very clear distinction across languages. Okay, our final question, which I'll be talking about, is whether styles of curiosity are associated with population level variables, such as mood, education, well-being, and inequality. So in our laboratory data, we used the parameter of our foraging model, capturing the regularity of how people search space. And we found that depressed mood and anxiety correlates with constrained, yet kind of like these regular, kind of consistent search patterns. These regular search patterns are thought to help people regulate mood and uncertainty, but they're also less optimal search patterns for finding resources according to our model of foraging. So there's this trade-off between regulating our mood and uncertainty when we're exploring new and novel and uncertain information with finding information of value, at least according to our foraging model. We also looked beyond the laboratory data at the mobile app data. And here we're looking at if topic efficiency versus topic diversity across countries is related to sociodemographic variables. So one thing to note here is that topic efficiency is measured as the average shortest path distance of each reader's graph. And it's very strongly negatively correlated with the topic diversity, which is measured as the entropy of the topic proportions of each reader. So countries that scored higher in surveys by the World Health Organization and other organizations on spatial navigation, positive affect, developmental indices, education, and equality tended to build, all of those countries tended to build looser and more diverse knowledge networks like busybodies. And this is consistent with some theories suggesting that there's a benefit of kind of this kind of more diverse browsing in order to kind of put yourself in a more enriched environment. One result I want to highlight here is that we found that countries that reported higher negative affect from the World Happiness Report tended to have readership that created tighter and more constrained hunter-like knowledge networks. And this is consistent with our laboratory results that I just showed you on the previous slide, relating more constrained search patterns with depression and anxiety. So to conclude, we replicated the hunter and busybody kind of network styles identified in the laboratory data with naturalistic mobile app data. And we found that, interestingly, our foraging model from the lab data was most similar to mobile app data compared to some alternative null models. the knowledge network architecture across 14 languages of Wikipedia consistently was associated with hunters seeking STEM topics and busybodies seeking culture and geography topics. We found that depressed mood and anxiety correlate with this kind of efficient and familiar yet narrowed search pattern, and that this was also found to be the case with negative affect in the mobile app readership. And for more about, for instance, the dancer style, please check out our paper. From these conclusions, we really wanted to do some future work on what network structures build kind of resistant knowledge structures or vulnerable knowledge structures to things like disinformation or misinformation, and what the drivers are shaping how styles of curiosity relate to those socioeconomic variables like inequality and education. And we were also wondering how flexibly someone can move between diverse styles of curiosity and how that relates to things like mood and well-being. And finally, we were wondering how intervening on someone's style of curiosity, such as via a recommendation system or recommendation algorithm, alters mood and memory for what people have read. So thank you for your time, and I look forward to any questions.
Yeah, thanks for the great presentation, Dale. I see we have a couple of questions maybe coming in from the room. Patrick, would you like to unmute and ask yours?
Sure. Hi. Thank you very much, Dale. That was very interesting. I was sort of wondering, sort of on a methodological basis, but also in terms of what this means for navigation and organizational knowledge. You said how different, how the busybodies and the hunters preferred like different topics, say. Is that accounting for the network structure of the information on Wikipedia already? Are they like busybodies relative to how STEM is organized, or is it, or could it be potentially the case that the information in STEM versus geography versus whatever else is organized differently, which lends itself to different kinds of navigation patterns on that information? And I guess that applies across topics and of course across across languages, yeah, and across languages as well.
Yeah, that's a great question. So just to rephrase it to see if I understand, you're asking kind of like, are the patterns we found characteristic of the readers, or are they more characteristic of Wikipedia's structure? And yeah, that's a great question. And the results I showed you are all in relation to readers as in comparison to a null model on the Wikipedia structure. So we compare all of our results to a reference of just baseline. If someone were to browse STEM pages randomly,
right.
You know, like how busybody-like or hunter-like their browsing would be, and we do that for every topic. And so that's kind of how we capture, underlying, yeah.
And then the sort of follow-up is then, if you don't, well, can you characterize the information organization as more busybody-like lending or hunter navigation pattern lending, independent of how people navigate on it as well?
Yeah, so we use statistical methods to say that you know, the reader's behavior was not explainable by just the structure of the STEM pages or the history pages. Yeah.
Cool. Thank you.
Yeah.
I know we have a couple of questions coming in from YouTube. Caroline, would you like to present those?
We do, yeah. Can you hear me okay?
Mm-hmm.
Great. So our first question asks, is the foraging model developed from this open source? I'm wondering if it would be possible to input your own reading history and see which type you would be classified as. So the question is this foraging model developed from this open source?
Yeah, that's a great question. We would love to develop tools where people can kind of plug in their browsing history and find it for themselves. Right now, we haven't developed that, but the foraging model is open. There's code associated with this paper. In fact, the one of those earlier figures I showed you, let me see if I can get there quickly. Oops. So that's, oh, wow, this is troubling. Okay, I'll just do it the old-fashioned way. This figure I'm showing you on the right is kind of how we envision someone navigating many pages over time, and we kind of called this animation like sparking curiosity. And you can kind of get a sense of how loosely or tightly someone is navigating a space by just looking at the temporal progression. So if someone wanted to create this figure, we have code available. And yeah, we'd love to develop a tool where people can analyze their own personal histories. I think that'd be really interesting.
Thanks so much, Dale. Our next question from YouTube is, considering that the app users are so few compared to the people using the mobile, web, and desktop, if I recall, less than 2%, could it be that these users are outliers and may not behave like the large masses? And we also had someone +1 that question and say, also the same person could have different behaviors with the web browsing and mobile app. Let me know if you need me to repeat any of that.
Yeah, no, those are great points. So I think to address the first point, that was the similarity between the structures created by the web browsing in the laboratory and the mobile app browsing in the app data was why we compared all those network structures across data sets. And I hope that we showed that there was a convincing amount of similarity between the structures created by readers. But as I mentioned earlier in the talk, there's definitely not much content overlap. And what's really nice about a network science approach is that you can still compare the structural patterns of browsing by kind of abstracting away the exact kind of content that's being looked at. And I think the second, sorry, what was the second part of the question?
Sure. So
topics.
Yeah, someone had +1 to that question and said, also the same person can have different behaviors with web browsing and mobile app. So not a question, but I didn't know if you wanted to speak to that difference in behaviors across platforms.
Yeah, no, that's a really good point. People in the web browsing data had a different ratio of being referred to from other web pages, or just using like the search bar has a different kind of frequency. We tried to compare that different behavior using, again, those kind of alternative models. So we simulated like a random walk on the underlying hyperlink network, and we allowed the agent kind of randomly walking around the network to, with a certain proportion, navigate according to like referral links, or according to the popularity of the page, or according to kind of other like reader characteristics. And we found that across the data sets, those models were pretty similar to both the laboratory and the mobile app data set. So I think that suggested to us that we could characterize at least the network structure of these data sets in a similar way across modalities.
Thanks so much. And then if we have time, I've got one more question from YouTube. The question says, I'm not sure I understood correctly, but you started assuming there were 2 types of curiosity and fitted the levy flight accordingly. And then the second question is there a large variation of parameters among, say, hunters?
So I think the question is, did we assume there were only 2 types of curiosity? And maybe the answer to that is no. We were inspired by the philosophical text suggesting that there's these 2 consistent types, but we don't believe that those are the only 2 types. And I think that's very evident in when you look at like these spaces of network structures that are possible to create. And our 2 styles were only a small part of that space. And then in terms of fitting our foraging model to the data, so we really only had two parameters here, where one controlled the probability of repeating a page visit, and the other parameter controlled the distance of going from one page to the other. And so here we didn't want to explicitly presuppose these hunter and busybody style, because we felt that would be a little bit circular. And so we wanted to fit ideas more from animal navigation and spatial navigation in these parameters, and then see if the parameters were related to network structures created by a hunter or a busybody.
Thanks so much. Those are all of our questions from YouTube for now. I'll keep monitoring it.
Great, thank you.
Yeah, thanks for helping to relay those, Caroline. Dale, thanks again for the great presentation and also taking the time to field some of these questions that have been coming in. Just keeping my eye on time, I think we've got to transition now to our next speaker. So Patrick, I'd welcome you to share your screen and kick it off.
Oh, will do. Can you see that one okay? Great. Okay, so yeah, thank you very much for the invite. I'm going to be talking about a few different projects about collective attention across Wikipedia and the web. Some of which is similar-ish to what Dale has been talking about already with regards to networks and navigation and attention. So let's get going. So first up, I'll be talking about the Wikipedia News Network, how people respond to news events by browsing Wikipedia. I'll then talk about how people use social media and Wikipedia in different ways, and how they navigate to Wikipedia from social media using two different projects based on the depths of Wikipedia, the meme page, and a Wiki Reddit dataset that we've recently put together. So the Wikipedia News Network, this is based on, well, it's partly my PhD, but it was based on this paper, Between News and History, identifying network topics of collective attention on Wikipedia. So the thing about Wikipedia, right, it's special as an encyclopedia. Not only does it contain lots of historical old information, but it's live updated as news events happen in the world, and people try and negotiate what is notable, what is important, and what should be recorded and how it should be recorded. As such, it reflects what's going on in the news, obviously. And in my PhD, I wanted to study this link between Wikipedia and the news. So I needed to find news and current events on Wikipedia. One of the places you can do this is the current events portal. And in the current events portal, there are listings of events that have happened on any given day, sometimes with a link to a dedicated article, but more often than not, with links to a selection of related articles. And these related articles might be very related, might be not so related. They may just be, so for example, the country that an event has taken place in. So I had this data set of 1 year of events from the current events portal, and had all the articles that were linked there, the neighboring articles to these articles, and the page views to all of these events. But I was kind of stuck because I didn't know how to identify which article were really related to a news event, right? Is it all of the articles that are listed in one of these listings? Is it more than these articles? Is it articles that have a similar shape spike in page views or are linked to the articles in these listings? This was all very uncertain to me. So there are two sort of ways where you could identify related articles. One was to use the hyperlink network. This tends to specify more long-term relations in terms of relations between concepts of articles, and doesn't capture short-term patterns as much. And then there's also article page views. This might capture short-term associations. If two different articles have a very similar times and similar spike in page views, it might indicate that they're related to the same event. But these associations might just happen by chance, and figuring out whether they how closely related they are is very computationally expensive. So what I wanted to do is I wanted to find the articles which were both close in the hyperlink network, clustered together in the hyperlink network, and also had these spikes in page views to identify the groups of articles that were related to a particular news event. And so the way I did that is with what's called a temporal community detection approach. And what that gave me was a bunch of groups of articles that were nominally related to a particular news event. Once I had all of those articles related to a news event, I could do lots of different things. One of those things is identify the kinds of news topics that are represented on Wikipedia. And I did a bit of extra clustering here. I won't give you the details again. And when you label all of these, we end up with a bunch of different topics that can be organized in various different ways. I give you a preview of them, some of them here. The sort of headlines from these topics are that people tend to browse news on Wikipedia first in reference to a background concept space. So usually there are some clusters of topics that are related to these background concepts. These background concepts tend not to have very highly spiking page views, but are very much present across lots of different news events. So usually events are grounded by their geography, by countries. There are broader topics like hurricanes or US presidents or global finance that attract lots of page views, but not in a very spiky way. There are strong geographical effects, as I previously noted. There are references to locations of things, obviously, but there's also a discrepancy in the kinds of places that that receive attention on the English Wikipedia in terms of news events. So I contrast here that Spanish politics has only one topic associated with it, whereas there are these 5 different topics across US politics. There's also this focus on individuals. There's a real sort of obsession with celebrity. This aligns with some news value theory. Often there is a prominent individual, such as Donald Trump or Harvey Weinstein or Putin, in the examples here, that is associated with a news topic. And there's also some what we call breakout subtopics. So sometimes there is one underlying topic which bubbles on for a long time, such as Israel-Palestine relations, that then creates its own separate subtopic when there's a flare-up around a particular narrow event, in this case, the Gaza border protests. So events manifest in themselves in different ways. There are different kinds of articles. This is useful in and of itself, but what it was really interesting for me was being able to use this over the rest of my PhD and applying this in terms of asking what makes an event news. So taking properties of Wikipedia pages and then predicting actual news coverage. And then also taking Wikipedia page views and trying to predict the spikes and how and over what length of time levels of attention will decay towards a particular topic. So the takeaways here are that collective attention in response to current events, much like the curiosity-based browsing that Dale showed us earlier, is not confined to individual articles, right? And we need to consider attention, navigation, and contributions across the network to truly understand information demands and the processing of events. And this temporal community detection method that we create allows one to extract the Wikipedia articles that are relevant to some current event. And then you can study, let's say, the page views or the edits or the contents of the articles related to that event in more close detail. So that's that first paper. I next go on to the depths of Wikipedia. So depths of Wikipedia is a group of social media accounts highlighting the weird and wonderful of Wikipedia run by Annie Roeder here. These stats are maybe a little bit old, but it has millions of followers across different social media platforms. And it spawned various spin-offs as well. So what is in the depths of Wikipedia? So these social media accounts highlight weird and wonderful things. such as this post of a googly eye attached to a hammer on the article for googly eyes, or strange comments by politicians. George H.W. Bush made some questionable comments about broccoli, and it's attracted attention on social media via Wikipedia. So depths of Wikipedia highlight weird and wonderful things in Wikipedia. I wanted to know, can we measure the depth or unusualness or interestingness of a concept in Wikipedia based on data from these social media accounts? I wanted to know what the effects on Wikipedia are of this regular viral social media traffic. And I also looked at how Wikipedia article properties might predict article popularity on social media. So I take data from Twitter, around 18 months of tweets, from the depths of Wikipedia account, the Wikipedia account, and all tweets from all users with a link to Wikipedia. And you can see with the depths of Wikipedia page that not only is there a screenshot of the funny thing, but also a link to the Wikipedia page in the reply. So I take the articles linked from the depths accounts, from the Wikipedia account, and from the rest of Twitter, and try to quantify depth in different ways. So there's this attentional depth, which is based on Wikipedia page views, things which attract fewer page views before being posted. I operationalize as being as having more depth, as being more unusual. We take structural depth, so this is based on the position in the Wikipedia article network. Usually this corresponds to an article not receiving many links from other articles. There's also navigational depth, which is related to the above as well, which is based on the position in the Wikipedia navigational network. So this is how many viewers travel from elsewhere on Wikipedia to reach a particular page and whether it's particularly low. And I also take a measure of textual depth. So this is based on how unusual the words are in the Wikipedia article being used. So on these results, across a bunch of different measures, attentional depth, structural depth, navigational depth, and textual depth, we find that the depths of Wikipedia articles are more unusual than those posted by Wikipedia and the rest of Twitter. However, if you consider the Wikipedia as a whole, there are lots more unusual articles which could be selected. So Annie Rawler is still in a job on the depths of Wikipedia accounts. There are many more unusual pages that can be found. I next think about the on Wikipedia effects. So in terms of page views, essentially we find that peak views increase by 25 times when an article is featured by the depths of Wikipedia account, and that the excess views over the course of 1 week increase by nearly 10 times when an article is featured by the depths of Wikipedia. So a lot of attention is driven towards Wikipedia by the social media page. I also consider edits and find that edits increase by a factor of around 2 times when an article is posted by depths of Wikipedia. Articles posted by the Wikipedia account also exhibit increases in edit rates, but this is likely due to other exogenous factors. The pages posted by depth of Wikipedia tend not to be in the news, whereas the pages posted by Wikipedia accounts tend to be related to current events already. You also see new editors as a result of this posting from depths of Wikipedia. I estimate around 500 new editors as a result of their posting over the course of 18 months. And these 500 new editors have contributed around 15,000 new edits across the rest of Wikipedia. So content from depths of Wikipedia is measurably more unusual than Wikipedia content on social media. And this activity drives substantial short-term attention to Wikipedia and has inspired many new editors. Finally, this is a very recent project. This is a recent dataset paper which we've written. It's not quite published yet, but you can access the dataset already. This is the WikiReddit dataset. So this is done with collaboration with people with other academics at the University of North Carolina, and In this paper, we're interested in linking Wikipedia activity and Reddit activity. Reddit is one of the most popular websites out there at the moment. It is a discussion website and news aggregator. So people will often make posts on Reddit, and as a forum, Reddit allows people to respond in comments. And we are interested in how Wikipedia is used on Reddit and the effect of Reddit on Wikipedia. There's been some good work on this already. Gotzi et al. Looked at Reddit and Wikipedia data in the wake of the COVID-19 pandemic. And there's also some interesting work by Nicholas Vincent and Brett Hecht and Isaac Johnson on the call as well, trying to estimate Wikipedia's, Reddit's, trying to estimate Wikipedia's value to Reddit and how much value Wikipedia contributes to Reddit based on how much it's used, and correspondingly how much Reddit contributes to Wikipedia in terms of new knowledge contributions. We're looking to build on this by creating a larger data set that can allow more research like this. So this data comes from the Reddit for Researchers beta API program and takes 4 years of Wikipedia mentions on Reddit. Over these 4 years, there are over 10 million Reddit posts and comments with 12.2 million Wikipedia links. These are to 1.3 million unique articles across nearly 300 languages. So across nearly all of the Wikipedia languages. The Reddit data, we have hashed or anonymized IDs for the posts and comments and users. Then we also have some metadata for the posts and comments as well. So these are things like timestamp, the scores, so you can upvote and downvote things on Reddit to indicate whether it's useful or not, and post language. We don't include post and comment content because this would be quite de-anonymizing. But if researchers have access to the Reddit API, they can repull this content and supplement it with the Wikipedia data that we have linked to this data as well. For the Wikipedia data, we also take article page views plus or minus 10 days from them being posted. We look at the revision history plus or minus 10 days. And they'll also collect some supplementary data like redirects, Wikipedia IDs, and Wikidata IDs. So we do some exploratory analysis of this data, but would like others to do even more. We look at Wikipedia use over time on Reddit. Posts mentioning Wikipedia decreased from around 300 per day to 200 per day over 4 years, but the comments are more stable. We also see that scores, so essentially how well Wikipedia mentions and Wikipedia posts, Wikipedia links perform on Reddit are also relatively stable over this time. So Wikipedia is unsurprisingly useful for the rest of the web. We are interested in why this decrease might be happening. It might be due to platform policy changes, such as how Reddit is prioritizing more image and video-based content as opposed to textual content. But more work should investigate this. We also look at Wikipedia activity. So compared to the week before posting, for Wikipedia links that are posted on Reddit, we see a 45% increase in page views on the day of posting as compared to before, and around a 5 to 6% increase in the week after posting compared to the week before. There are some effects of edit counts, but these are quite weak and require further investigation, mostly because most of the pages posted do not receive any edits across this time. In this case, in contrast to the Depths of Wikipedia paper, this activity is less likely to be, this association between Reddit link and Wikipedia page views is less likely to be because the link was posted on Reddit, and is more likely to indicate some common exogenous source of some common exogenous events which drives attention to both Wikipedia and Reddit simultaneously. The audiences here are not passive news receivers. They consult different online platforms to support the comprehension of current events. We also look at linking behavior by language. So it's a very English-dominated data set, frankly. 95.8% of Reddit posts here are in English, and 93.9% of the linked Wikipedia articles are in English. However, there is substantial cross-lingual linking. Over half of the non-English Wikipedia links on Reddit come from English language Reddit posts. So there are maybe some knowledge gaps on English Wikipedia, or some interesting things on non-English Wikipedia, which English Reddit users are using to supplement their discussions. Other languages also link to English Wikipedia a lot. So here we looked at the proportion of links from the English Wikipedia we looked at the proportion of links to the English Wikipedia versus total links from non-English Reddit posts. We see that there are some larger Wikipedia languages that don't rely on English Wikipedia quite as much, whereas there are some smaller languages which rely on English Wikipedia links far more. This has perhaps some worrying implications. Language editions with knowledge gaps in particular areas use English instead, but then don't get the spillover benefits of Reddit users going to Wikipedia and editing Wikipedia in their native language. This might create some sort of vicious cycle. We think this could be used to study cross-platform attention, as I've mentioned already. We could think about Wikipedia's use on the social web, why it is used in Reddit discussions. Usually it is used as a source or a fact check, and this data set will help that study. We can think of how Wikipedia attention is distributed across different topics and how that aligns with different sources. Users on Reddit will go to Wikipedia for different things than search users, for example. We can also think about Wikipedia contributions towards societal benefits and harms. Both Wikipedia and Reddit have had scrutiny on them for their sort of overly white male user base, and we want to know how and why Wikipedia links might be used in different communities on Reddit by different users on Reddit around these topics as well. So our conclusions. Why does this study all matter? So we have this API apocalypse, right, where research data is becoming more difficult to access across the web, and platforms are driven more by profits and meeting certain metrics, or subject to various bot campaigns or manipulation. We can't take platforms at their word. We need to combine their metrics with other sources to really understand what matters beyond platform-specific vacuums. And we need to understand sources and destinations of traffic, platform dependencies, and potentially extractive relationships with the digital commons as well. Thankfully, we have this trustworthy Wikipedia open API access, and this can act as a sort of standard candle for measuring cross-platform attention across the web and across news, across different social media. We want to understand the social, editorial, and algorithmic factors that shape our collective attention across the whole web, and Wikipedia is a really big part of that. So thank you very much. You can contact me on Blue Sky or over email, and here's references which I referred to earlier. Thank you.
Yeah, thanks for the great presentation, Patrick, and walking us through a number of different lines of work there that you've been involved in. As we get into our question and answer session here, I think we have a couple of questions coming in on YouTube. Caroline, are you ready to relay some of those?
Sure. Our first question asks, could one use your findings in your first paper to sort of find missing articles or types of articles that readers would have read if they existed?
Interesting shout. Yeah, I think on the first paper, so the first thing I would think of here is looking at it from a cross-language perspective, right? you could identify the groups of articles in one language, let's say English, that are attracting attention in response to a news event and do not exist or do not have an equivalent in another language, which you could then create in this other language. In terms of within a single language, it's hard to say what should be there and what shouldn't, what should not be there, because sometimes people just add information about one news event to an existing article. I don't know if anyone else has any ideas on the call about that, but I think it's something we could think about.
Our next question asks, have you looked at any of the deepest articles of Wikipedia according to your score? And if yes, how amusing were they?
So where are we? The deepest articles. I've not got examples here. Across different measures, you get different things for deep articles. So what would be closest to sort of the most amusing ones would be the ones in the deepest textual depth. So these are ones that use the most unusual words. And some of these words, I give one of the examples here, fnord, are basically used once in that article and nowhere and not at all elsewhere. Unfortunately, a lot of the there was a lot of sort of dregs or silt, or what's the right word? Yeah, there's lots of sand at the bottom of the seabed, right? And so a lot of the attentionally deep and structurally deep articles and navigationally deep articles are very niche specific things around, for example, a random sports event which happened in 1991, or a person with they're usually stub articles, right? A person with a one-line biography that no one ever looks at the article for. So so you do have to mind the depths. It's not just there aren't lots of treasures there.
Excellent, thank you. Our next question is, would it be worth adjusting for the number of readers of a Reddit post compared to the reach depths of Wikipedia has in their social media posts to see which has the best conversion rate?
That would be great. One thing with the Reddit API, at least for now, is that we don't have number of readers indication, but you could go based on, for example, number of comments or score as an indication of the attention towards those posts. One annoying factor here is that whilst Reddit has now sort of reopened its API with this research program, the Twitter, or now X, API is much less accessible. But we could potentially compare across the different time periods and see who wins out. I think it's interesting across the different papers as well, in that with depths of Wikipedia, at least, the people who read and engage and then go to Wikipedia tend to be people who are more interested in Wikipedia and are then more likely to, well, firstly go there and edit and convert. Whereas the Reddit readers, it's used more broadly across Reddit. So the conversion rate to edits is, I expect, will be lower.
Thank you. And then we had a couple of people ask if we can drop the link to the paper into the chat on YouTube. So we will do that momentarily. I'll get some help from Isaac for that.
Thank you.
Thanks, Caroline. Pablo, yeah, let's go over to you with the question.
Thank you. Well, thank you to both speakers for sharing these great talks. I have a question for Patrick. So I was wondering, in your analysis of the effects of the Twitter account, the depths of Wikipedia, if you maybe you mentioned that, or maybe this possible future work, if you analyze what kind of editors engage with these articles that are being featured by the account. I'm asking this because if this could be an opportunity to engage with newcomers or some audiences that are missing in Wikipedia, but because of these other platforms, they can bring them to be part of the Wikimedia community.
Sorry, can I just clarify, was that looking at the depths of Wikipedia users and what they
Yeah, like
sorry.
if there is some effect from the depths of Wikipedia, for instance, in bringing newcomers, like new accounts.
Yes, absolutely. So yeah, I had that here. So this was looking at the I don't know across which specific articles these were. I could find out. But looking at the first time logged in editors, so essentially new editors who edited one of the depths of Wikipedia articles within the week after the tweet was posted, and we saw across 18 months there were about 500 new editors. And then these first-time logged in editors, I don't know what exactly they edited afterwards, but they then contributed 15,000 new edits over the a course of the next over the course of the rest of the analysis. So yeah, it attracted new editors. I'm not sure how this compares to things like editathons and, for example, Reddit, but it works. Yeah.
Thank you.
Caroline, just checking in. We might have one more from YouTube.
We do, yeah. So someone asked first if they said they would particularly like a link to the news article that you shared, if possible. We'll see if we can get that. And then that same person asked, said that the depths of Wikipedia insight is useful. Have you been able to compare that conversion rate to editing with other types of articles?
Other types of articles being non-depth articles, I assume here. So the useful thing with the depths of Wikipedia accounts is that it finds things that are not popular before and then and posts them, which means it's easy to analyze the conversion rate, right? The difficulty with other kinds of articles, for example, ones that are already popular in the news or being posted by the Wikipedia accounts, usually the same thing, is that I would need a much more rigorous sort of methodological causal setup to identify how much is from the Wikipedia accounts. That's sort of the thing that I'd like to do when turning this into a full paper, because it was just a Wiki workshop presentation. You can see the full video there if you'd like to. It's something I'd like to do. It's more difficult, and then finding those other articles. Yeah, it's the ultimate question, right? Like where do these editors, where do these contributions come from? How can we best get good edits on Wikipedia? Or different domains. Yeah, you could link it to the topic classifications that you can get from Wikipedia as well. I've not done that here, but in principle, one could do that. There'll be different topical classifications within the depths of Wikipedia articles posted as well. So maybe some of those will do better than others. Good point.
All right. Well, thanks again for filling those questions, Patrick. I think we need to move to wrap up for today. So I just wanted to extend again a thanks to both Dale and Patrick for sharing a lot of interesting work that has helped us explore both our individual and collective attention on Wikipedia. Sort of really fascinating work to walk through today. And with that, I'll pass it over to Kinneret as we conclude the showcase.
Thank you, Eli. And thank you everyone for joining us today for this research showcase and for asking questions in the discussion. And again, as Eli noted, a special thank you to our speakers, Dale and Patrick, for your research work on Wikipedia and for presenting it here today with us. The Wikimedia Research Showcase is made possible thanks to an awesome coordination team. So thank you to Eli, Miriam, and Diego for helping us. Also, thank you to Eli for hosting the showcase and Caroline for fielding the questions today for the Q&A. Our next month's showcase for February is all about Wikipedia admins. So we'll discuss administrator recruitment, retention, and attrition. So we're looking forward to seeing you all there. Thank you. Okay.